Welcome to qnawire.
In this question, we're looking at a double slit experiment. So for the double slit experiment, the equation that we want to use is d sine theta equals to n lambda. Well, in this case, d is the distance apart, right, between the slits. The angle is the angle made, right, for the minima or maxima from the central maximum, right, depending on your n value, right. Lambda is the wavelength of light or the electron that we're looking at, and is the order of the diffraction. So n, if it is a integer value, this is constructive interference. This is where you get a maxima. But if they are half integers, right, this is where you get destructive interference or minimus. Right, so we get the minimus over here, and we are interested in the minima because we're looking at a dark fringe. So the first dark fringe will be when n equals to half, and we are given that this is at 18 degrees. We can use that knowledge to find what is our wavelength of our electron, and from this wavelength of electron we can use the de Broglie's wavelength formula, right, where p equals to h over lambda to find the momentum and hence the velocity to determine whether these electrons are relativistic or not. So we start off substituting in the slit difference, which is 1.25 nanometers, sine of 18 degrees equals to half times the wavelength. So the wavelength over here will be 0.7725. So it was just 7.725 times 10 power minus 10 meters. Equate this to h over p. Therefore, our momentum, we can just immediately find the velocity by taking h over m times lambda. Where m is the mass of our electron. Lambda is the wavelength which we have previously found. And the velocity that we get is about 9.42 times 10 power 5. Notice, divided by the speed of light, right, which is 10 to the power 8, just approximately 0.3%, right, which is a very small amount, so it is still not close enough to be relativistic. So we can assume it to be non-relativistic. Now to find what is the potential in which the electron is accelerated across, right, we can equate the kinetic energy that is gained by this acceleration to the charge of the electron multiplied by the potential difference. Right, this would be the total energy gained during its acceleration. This is equals to the kinetic energy of our electron. Right, assuming that the electrons actually are accelerated from rest, right, as given in the question. So therefore, we just have to substitute in all the values. half. Right, half mv squared equals to q times v, right? But we only want the potential difference v, so we divide away the charge of the electron. And we should get about 2.52 volts.